Okay, really picture this process unfolding. What we're looking at right now isn't a human developer furiously typing away at a mechanical keyboard at 2 a.m. No way. This is an AI agent, and it's operating entirely autonomously within a terminal environment. Just track its process for a second. First, it's actively exploring a massive repository, right? It's reading through existing files just to build context. Next, it actually forms a strategy, planning out the exact changes it needs to make. And then it dives in, actively editing the code across multiple files. It even automatically spins up the test suite to verify its work. But wait, there's a failure. You get that dreaded red error log cascading down the terminal. Now, in the past, that meant a human debugging session. It meant pulling up Stack Overflow, tracing stack traces, and basically burning hours. But instead of throwing an alert and waiting for a human to step in, the agent instantly ingests those error logs, analyzes exactly where its logic fell short, adjusts its approach, and writes a patch for its own mistake. Boom, the tests go green. It just autonomously debugged its own broken code without a single human keystroke. And seeing that level of autonomy play out in real time brings us to a pretty jarring reality. AI can now handle an increasingly large part of the software development loop. So, what exactly is the developer's role? It's a massive, honestly kind of existential question that every single person working in tech right now, from junior front-end engineers all the way to seasoned back-end architects, is asking themselves. For decades, the main bottleneck in software was the physical act of translating logic into syntax. But now that the machine can handle the syntax and even correct its own logic, we literally have to completely rethink what it means to be a developer.
Welcome to This Explainer. Today, we're diving into the shift in software development, moving from simple autocomplete to multi-agent orchestration. We're going to break down some fascinating insights from tools like Cursor and Anthropic's Claude Code to show exactly how these autonomous systems are fundamentally rewiring the entire industry. Let's get into it.
Right off the bat, we need to completely shatter this myth that modern AI is just some glorified autocomplete. The difference between the old way of doing things and the new way is night and day. Think about the traditional loop we're all so used to. A human thinks up a solution, types out the code line by line, runs the tests, debugs the inevitable syntax errors or logic flaws, and finally ships the feature. It is incredibly manual, very step-by-step, and totally constrained by human fatigue. But the agentic workflow, it flips the script entirely. Now the human's role shifts to defining the high-level business goal or the architectural constraint. From there, the AI takes over the execution loop. It explores the repo, drafts the plan, implements the logic, evaluates the tests, and iterates on its own failures, exactly like we saw in that opening terminal sequence. The human only steps back in at the very end to review the logic and approve the merge. And why does this matter so much? Because you are no longer the typist. You are the director.
But how does this actually work under the hood? I mean, it's not magic, and it's definitely not just sending a raw API call to a large language model and hoping for the best. Platforms power these autonomous loops using something called an agent harness. Think of it as the foundational engine. It combines three core components. First, instructions. These are the absolute system rules and guardrails that guide the AI's behavior. Second, tools. This is huge. It's giving the AI the ability to actively search entire codebases, manipulate files, or even execute bash commands in a terminal. And third, the underlying models themselves, like Claude or GPT. This harness is what actually orchestrates the AI's environment. It makes up for the fact that raw models can hallucinate or get stuck. By putting the model in a structured harness, the system lets the AI use tools to verify its own assumptions. It starts acting way more like a methodical human developer and way less like a simple chatbot. Now, the real secret to making that harness actually produce good code, it's all in how you kick things off. If you just toss a massive, ambiguous feature request at an AI and tell it to start coding, it's going to get totally lost in the weeds. That's why the absolute most critical phase of this new workflow is plan mode. During plan mode, before it writes a single line of functional code, the agent deeply researches your codebase using semantic search to understand your established patterns. It might even pause its execution to ask you clarifying questions about your specific requirements, which is wild, right? It shifts the dynamic from a passive tool to an active teammate. Then it outputs a highly detailed step-by-step implementation plan and waits for your green light. A recent study from the University of Chicago actually pointed out that highly experienced senior developers spend significantly more time planning before they code compared to juniors. As it turns out, if you want senior-level output from an AI agent, you have to force it to follow that exact same methodology.
Okay, so if one autonomous agent following a structured plan is a massive productivity boost, what happens when you remove that single-player constraint entirely? Well, we enter the multi-agent reality, and this is where the paradigm completely shifts. The fundamental unit of developer productivity is absolutely no longer one developer working on one task. Just imagine this scenario. At the exact same second, literally t plus 0.01 seconds, you have multiple, highly complex operations firing off in parallel. Agent 1 is deep in the weeds investigating a nasty back-end bug that requires massive context. At the exact same time, Agent 2 is building out a brand new front-end feature, perfectly aligning it with your UI and UX standards. Meanwhile, Agent 3 is busy writing an exhaustive automated test suite for that exact feature. And Agent 4? It's actively conducting a critical security review on a pull request you submitted an hour ago. Every single one of these tasks requires distinct focus and edge case thinking, yet they are happening concurrently. You, the single human developer, are now operating with the output capacity of an entire dev shop. You're acting as an engineering director managing 4 distinct streams of work at once. It's unbelievable.
Now, practically speaking, if you tried to run 4 complex iterative AI agents at the exact same time on your local laptop, the fans would spin up like a jet engine and your machine would probably just melt. That sound of laptop fans used to be the anthem of human productivity, right? But today, that heavy lifting is being outsourced. The industry is rapidly moving toward cloud agents. These agents are deployed into their own isolated, highly scalable virtual machines up in the cloud. They don't have to compete with you or with each other for your local computer's memory. And because of this, they can operate autonomously for hours or even days at a time. They literally don't sleep. You can have them crunch through a massive 48-hour database migration script over the weekend while you are completely offline, building and testing in remote environments, and they'll just hand you a fully verified merge-ready pull request by Monday morning.
Let me give you a super concrete example of this autonomy in action. An agent can independently spin up its own local development server right inside its virtual machine. It can then open a headless web browser, navigate through the rendered pages, and physically interact with the UI. It'll click on dropdowns, input text into forms, or even toggle the theme to dark mode just to ensure the CSS renders correctly. But here is the absolute coolest part. It actively records a video or captures screenshots of its own interaction to prove to you that the visual user experience is flawless. Because at the end of the day, trust is the new bottleneck in software development. We need undeniable proof that the AI didn't just write syntactically correct code, but that it actually solved the user's problem. So you just watch the artifact video, review the logic, and hit merge. Of course, whenever we're discussing systems with this much raw power, we absolutely have to talk about the elephant in the room. When you give an AI agent the ability to click around browsers, modify source code, execute shell scripts, and potentially access your databases, the risk profile of your organization fundamentally changes. The stakes are vastly higher than accidentally accepting a bad line of autocomplete. And that brings us to the absolutely critical responsibilities of security, sandboxing, and boundaries. There are a few essential safety strategies that organizations absolutely must adopt to survive this transition. First up, you need incredibly granular access permissions. The principle of least privilege is paramount here. The AI should only touch exactly what it needs for a specific ticket, nothing more. Second, you need strict environment boundaries. Those sandboxed virtual machines ensure that if an agent hallucinates a destructive command, it only wipes out an ephemeral, temporary container, not your actual production database. Third, you've got to implement automated review systems. We're talking about specialized AI tools like BugBot, whose sole job is to aggressively analyze the coding agent's pull requests to make sure it hasn't introduced any vulnerabilities or tanked your performance. And finally, extensive audit logging. This is basically your flight data recorder. When things inevitably break, you need a precise record of exactly what the agent decided to do and why. The golden rule here is simple. Unparalleled AI autonomy strictly requires unparalleled system boundaries. So let's circle back to that big existential question we posed at the very beginning of this explainer. If the AI is doing the planning, the implementing, the testing, and the debugging, what exactly are you doing? Well, we need to fundamentally reframe the developer's future. This isn't some dystopian story about human replacement. Not at all. It's an empowering evolution. It is quite literally the promotion of the software developer into a completely new, higher leverage role. Your competitive advantage as a human, it's shifting entirely. It is no longer about your typing speed or your encyclopedic memory of React hooks or your ability to manually configure Webpack. Your expertise is now strictly required for high-level system architecture design. You are the critical bridge managing the messy, real-world business requirements. You're the one orchestrating these fleets of agents, defining highly specific, verifiable goals for them to execute against. You're responsible for designing and enforcing those security boundaries we just talked about. And perhaps most importantly, you're conducting advanced code reviews. Because the AI is automating the routine, repetitive tasks, every single developer now needs to start thinking like a principal engineer. Your greatest asset going forward will be your judgment, specifically having the deep technical wisdom to know exactly when not to trust the AI's output. Think about how fast this is moving. We've rapidly gone from asking, can an AI write this single function, to, can I trust an agent to build this entire feature? The scale of what one person can accomplish is expanding exponentially right before our eyes. And the next logical leap, the absolute core insight you should take away from this explainer today, is this final provocative question. Can I give an entire project milestone to a coordinated group of agents? Looking at the trajectory of the technology, the answer is increasingly, undeniably, yes. The real question is, how are you going to adapt your skills to be the one orchestrating them?